Alright guys, today we're going to explain seafloor spreading. This helps explain Wegener's theory of continental drift. It was Hess who came along with his data to help us understand. This is a model. This is our subduction zone of our land, which is made of granite, and this is representing our ocean made of basalt. In the center, we have our mid-ocean ridge. It's called a mid-ocean ridge because it constantly has uprising magma that is cooling, creating new seafloor. As the new magma comes up, it comes across the seafloor. If we stop and take a look at this point, we can talk about several things. First, it's a mid-ocean ridge right along the center because we have two tectonic plates, one moving in this direction and one moving in this direction. Because of that, the magma is oozing up out and forcing them apart. That's why this is happening. What you'll notice are some red and blue colors. This is representing the magnetic polarity. On the south polarity, all of the material inside of the rock have their lining of their magnetic material in a certain direction, their domain. It reverses every now and then, so the domains flip. We can detect this, and that's what lets us know that this is new material. You see, if it was all the same age or the same material, they would all be colored red or all colored blue in a north position or a south position. But because they alternate, that was a piece of evidence that let Hess know we've got new material coming out. The other thing we can notice is the age. You can see here that the age of this rock at the center is 40 million years old. If I drill and take a sample at the outer edge, we'll see that it is over 76 million years old. That shows that the center is younger material than at the edge. Once again, helping prove that plates are moving and new materials oozing out of the center. But now the question is, does the seafloor grow and grow and grow? No, it doesn't. It actually stays the same size. So where's all this extra material actually going? Well, here's what happens. When our dense basalt material hits our land granite, basalt is more dense. The plate actually will subduct or go under the zone at the land because granite is less dense and the basalt is more dense, and we have what's called a convergent boundary. Convergent boundaries are when one land plate is colliding and hitting another. But because this is more dense, it will actually sink and go underneath the land. Same thing happens at this end. The land is converging on the ocean. The dense ocean basalt will subduct or converge and go under the land. This is why the seafloor never grows, but it does get new material. So what actually is happening? If we look underneath, we can see that the seafloor is subducting under. This material melts and can get recycled back into the center again, or can bubble up under pressure and create volcano zones. We often find volcanoes along these ridges where we have subduction because we constantly have recycling matter underneath. So this is why the seafloor spreading helped prove that plate tectonics exist. It subducts underneath, creating new fresh material in the middle. So this is a divergent boundary at our ridge. Divergent means to spread apart. When they come together over here, where they collide, C for collide, we have a convergent boundary. In this case, remember the basalt is heavy and sinks underneath. This concludes our understanding of seafloor spreading.